Hey, good evening, everyone. Am I audible?
Yes, good evening, ma'am. You're audible.
Yeah, thank you, Sushmita. Uh, we will wait for a few more minutes, right?
Yes, ma'am.
Yeah, okay. Just let me know when should I start.
I think we can start, ma'am. It's already 7:05.
7:05, no? Okay, give me
Yeah,
a minute. Yeah, that's
yeah, sure.
good evening, everyone. Okay, so till others join, okay, we will start with the recap of what we did yesterday. Okay, so yesterday we started with the union, okay, after completing structures, right? So union is also a user-defined data type. Then we have understood about the memory allocation of structure and union, okay. Did few examples on the structure as well as on union, okay, on the memory, right? Now we will continue with union, okay, because there are some topics which are remaining, okay, like how you're going to make use of structure in union and union in structure, okay, that example, and how you will be making use of pointers in union. Okay, so after this, we will be starting with a very important topic again, which is files, okay, handling files in C. So in this topic, we are going to go through what are the different, files functions available, okay, to read and write the character data, string data, binary data, okay. Then also we will, understand the byte, okay, the arrangement, okay, because depending on that also, okay, there will be the difference, okay, in reading the bytes. Then we will do some examples based on the files input output, okay, how to provide the command line arguments, okay, because still we have not done how you will be passing the command line arguments in the main, okay. So that is nothing but your argc and argv, right? And we will do one particular example, which will be showing you all the concepts, okay, what we have learned before, okay, along with reading and writing to the files, right? So that is what all about files we'll be doing today. And at the last, as I said yesterday, we will have one again quiz, okay, of 10 questions today also. Okay, so you will be giving quiz at the end, right? So let us start with the today's session. So I'm going to share my screen now. Let me know the screen is visible. So again, I'm going to, start with the union. Okay, so just have a quick recap of what is a union. Okay, so I shared my screen. I hope the screen is visible. Okay, you can just confirm that the screen is visible. Yeah.
Yes, ma'am. It is visible.
Okay, so we started with unions yesterday, right? And we have gone through how to initialize and access the members of the union, right? So union is again a user-defined data type that will allow multiple members to share the same memory. So here the size of the union important is the size of the union is the size of the largest member. Okay, so we have understood about the memory arrangement. Okay, what is padding, why this is required. Okay, and then what will be the total size. Okay. Then how you are going to access the union. Okay, so either by making use of dot operator or the pointer if you're making use of pointer. Then we have understood what is a type def. Okay, type def can also be used with structure. Okay, understand. This type def is used to give the LES name to this user-defined data type like structure and union. Okay, so today, again, I will be showing you one example where we can use this with the structure as well. Now coming to the combining union and structure. Okay, so two examples already I created. Okay, so I will be explaining and we will be running that example. So union is often put inside a structure to store different types of data in a single record. Okay, so we can have both. Okay, so we can have union inside a structure and structure inside a union, correct? Now, structure can also be put inside a union. So commonly used in real applications like device drivers, protocol handlers, and embedded systems. Now, a union can contain the basic data types, okay, our primitive fundamental types. It can contain arrays, structures, and other unions also, right? Because like nested structure, we can have nested union as well. A union allocates memory equal to the largest member, right? So if the structure is the largest member, the union size becomes the size of the structure. Okay. Now, why? Because the structure will not have overlapping and structure is going to have the size of the all members, correct? So if the size of the structure is the largest member, the union size becomes the size of the structure, correct? Now, in this particular PDF, what we have gone through yesterday, we did till here. Okay. Now, if you see, this is a struct inner. Okay. So we have got char a double d. Okay. Now, double, we know it is using 8 bytes. Okay. So typically size of 16 due to double alignment. Now, there is a union created. Okay. So union has got this integer x, which is of 4 bytes, and then the struct inner s, which is already created. Okay. So this is 16. So the size of the union is going to be 16 because that is what is the size of the structure. Okay, that is the largest size of the structure. Okay. So now what we are going to do, there are two examples. Okay, I have created. So one is we have got this okay type of I created a structure with the type def here. Okay, please understand. Okay, so this is union in structure example and this is structure in union example. Okay, both examples we will understand. So first is union in structure. Okay, so first of all, I created this structure employee. Okay, now you know that how to create a structure, how to give the output, okay, in the printf statement. Okay, so let us now understand this code. So we have got the structure and now I'm using this type def with the structure. See, the purpose of using a type def is nothing but here we don't have to write the struct keyword. Okay, so we are giving this particular name, that is the alias name, okay, for the structure like in union. So we don't have to write the keyword struct employee. Simply now we can make use of the employee and then you create a variable of the employee. Okay. Now in this case, we have got the employee ID and there is a union. Now this union is having a name info, okay, which is having the salary or hourly rate. Now this depends, okay, because if an employee is permanent, then salary will be given. If it is on contract, then hourly rate, okay. Then int employee type, okay, what will be the type of the employee, permanent or contract? That can be having a value is 1 and 2, okay. Now if you will see here, if you consider this employee as a structure, okay, the int and int, okay, that is 4 bytes, correct? And then we have got union, which is having 4 bytes again, okay. So this will be 8 and this is also going to be 8, correct? And we have created the employee. Now in the main, we have got employee variable created. Okay, we know how to initialize this employee ID and employee type. But when it comes to the salary, okay, now either you will have the salary or either you will have the hourly rate. See, out of these two, only one we are going to use. Understand, union going to override the value. So at one point of time, only one member will be active. Okay, one member is going to have the value, correct? Now, in this example, either the employee is permanent or the employee is on a contract. Okay, one employee will not be having both. Exactly. Okay. So here we are going to access, so E, that is employee.info, because employee has got this info, which is nothing but the nested union dot salary. Okay, so which is written 55,000, right? Now, before we display the value of these all variables, okay, we are going to now understand what is the size. So if you want the size of the structure employee, okay, so we are writing size of struct employee, okay. And then what is the size of a union? Size of e.info. Understand, here we are using e.info because info is nothing but it is a union, correct? Now, we know that this particular union will not have size 8, okay, because it is going to overlap, okay. So there is only one size which will be considered, okay. So at the end, let us see what is the size of both. Then here we are displaying the employee ID, okay. Then you check what is the employee type. So e dot employee type equal to 1. So this 1 is given, so I should get the salary. If the employee type is 2, then we have to provide the hourly salary, okay. So only one is, okay, is going to be used here. Fine. So let me now run this. Okay, let me now run this. So here we will use union in structure. Okay, union in structure. So A. Okay, so we are getting size of struct employee 12 bytes. Okay, now understand this is a 12 bytes. Okay, and size of union is going to be 4 bytes only. Size of union is going to be 4 bytes only. Okay, why? Because this is going to be 4 and this employee ID is 4. This employee type is also 4, but union is going to be only 4 bytes. Okay, because same memory is used, right? So total size becomes 12 and then we are getting the output of employee ID and salary. Okay, so this is the example of the union within a structure. Understand, here we are going to make use of only one. Okay, not two. So this is the example where, okay, only one particular member is going to be used at a time. Okay. Now, similarly, if you go to the structure in union example, okay. Now here, if you see, the struct coordinate is created, okay, which is int x and y. So this is going to be 4 and 4. Okay. Now union data. So this int n is 4. Understand, it is integer. Okay. So this is 4 and struct coordinate point. Now this is nothing but a nested structure in the union. Now, what is the size of this particular structure? The structure size is going to be 8 here. Okay, because 2 integers are there, correct? And this is going to be 4, right? Now, here in the main, okay, so what is done? So we have got union data D, okay, the variable is created. Then we are now displaying the size of the struct coordinate. So for the size of coordinate, we are simply using size of struct coordinate. And for union, we are using the union data. Okay, so what will be the size of the union? That will be, if structure size is more, that will be the size of the structure. Then we are initializing, okay, the values. So we have got D dot point, okay, that is this point, okay, dot x is equal to 10. That means through the union, okay, we are now accessing this structure ka coordinate by making use of this variable of the structure. Okay, so D, that is your union dot point dot x and D dot point dot y is equal to 20. If you want to give the data for this end, you know directly you can use D dot n. Okay. Now, what we are printing? We are printing the value of x and y. Now, write to n. Okay, so D dot n is equal to 500. Okay, and then we are printing the value of n. And then after writing n, okay, we are going to display what is the x and what is the y. Okay, so here let us understand the size. Okay, so I'm now going to execute that. So this will be the file structure in union. Okay. Okay. And let us see the output. So size of struct coordinate is 8 bytes. Okay. Size of struct coordinate it 8 byte. Understand? This is 8. So what is the highest? It is 8. Okay. Then size of union data is 8, including the padding. Okay. Size of structure is 8. So size of union data is also going to be 8. This is the highest. Then point is 10 and 20. Then n is equal to 500. Point is 520. Okay, because it is going to overwrite, right? And we are displaying the x and y. So this is going to be 500. Okay, first x was 10, but then we are writing the n. Okay, so the x is going to be 500 because it is going to overwrite on this, and then y is going to be 20 only. Okay, so this is how you're going to make use of the structure in union. Okay, so the structure is got the highest size. So this is going to be the size, okay, of the union, right? Now, next is, okay, let us do one example of how you're going to make use of pointer. That was not done. So I'll create a new file, okay, and let me now write the code for this, stdio.h. Okay, so then we will have the main. Okay, before the main, we will create the union. Okay, so let us create a union data again. And this is going to have some values, okay, of the member I. Then we will have the float, okay, and char ch, right? So let us save this. So I'm going to save this in day 11 itself. Okay, so this is going to be union pointer. Okay, union pointer. Now let us come to the main. So first of all, now see here how you're going to do this. So we have got the union data, okay, variable created. So this is the union variable. Then you're going to create the union data pointer. Okay, fine. So this is nothing but pointer to union. This is a pointer to union created, right? Now, what we always do with the pointer, we need to create the address. Okay, so pointer is equal to address of D. Okay, this is how we will be giving the address. So this is nothing but pointer points to union variable. Okay, points to union variable. Correct. So same way how we are doing this with the structure, the same way we are doing this with the union. Okay. So previously we did this with the variables, right? So it is one and the same thing. Now you will assign the values. Okay. So assign values. Okay. So if it is a pointer, you're going to make use of the arrow notation that we know. So pointer, now this arrow, okay, I is equal to 100. Again, in this case, okay, the values are going to be overwritten. Okay. So first we will print this. Okay. So we have got the integer, this is percentage %t. And then we want to print the value. So just write pointer this I. Okay. Now similarly, I'm going to copy this for the other. Okay. So this will be the second, that is your F. Okay. So let us write here. Okay. And we need to provide this value. So I'm just going to make the changes here as float. Then dot to F. Okay. And this should be F. And finally, we'll go with the character. So this is pointer ch. Okay, this will be a character. Let us say this is A. Then we are going to print the character. Okay. So this will be %c and then pointer to the character. Okay. And finally, we are going to write return C. Okay, so remember the concept here again, since union is going to share the memory. Okay, so writing this particular pointer F is equal to 12.5. This will overwrite the previous value of pointer I is equal to 100. And when you are writing pointer ch is equal to a, this is going to override the previous value of the float. Okay, so only one member holds a meaningful value at a time. Okay, so this is a union pointer. Let us go to the union pointer. Okay, this is the example. So int main, what is the error here? Semicolon is missing. Okay, so see here. Now you will be getting all because we are using the printf statement, okay, before we write the other, right? So the only thing here to know is that if you are using a pointer, then you're going to make use of this arrow notation, okay? So this is all about the union. Now let us understand what is the difference between the union and the structure. So when it comes to the memory allocation, structure has got the separate memory for each member. Union will share memory among all members. Okay. Size, the structure size is sum of all member size, and union is size of the largest member. Then feature all members are active. Yes. Okay. Because all exist independently. There is no overlapping. Here, it is not like the union where every particular member data is going to start from the base 0. Okay. But in the case of union, no, only one valid at a time. Then usage structures can be used for complex objects like records. And union can be used for memory efficient storage for multiple possible data types. Okay. And where only one member should be active at a given point of time. Okay. So in such type of applications, you can make use of union. Then just summarizing all the union features here. Memory allocation equal to the largest member. Members active, only one valid at a time. Memory sharing, all members overlap. Overwriting, new value overwrites the old value. Efficiency, very high, it saves memory, okay, because of the overlapping. Best use cases are embedded systems, okay. Then your protocols, network protocols, then unions inside the structure. Okay, that example of your employee where we are going to make use of only one based on the employee type, okay, whether salary or hourly salary. So these are some of the features of union. And finally, what are the applications of union? Okay. Again, union features are there. Union allocate memory equal to the largest memory because all members share the same memory. To avoid overflow, the memory block must fit the largest member. Unions are more memory efficient because they do not allocate separate memory for each member like structures. All members reuse the same space. All members of a union does hold values at the same time. Only the most recently written member contains meaningful data. If a member other than the one last written is read, the output will be garbage or unpredictable values. Okay, yesterday we have also seen this one example. Because the original bytes were overwritten, union is not recommended where all fields are required simultaneously. So in that case, you have to make use of structure. Okay, finally, the applications of union. In memory optimization, used in embedded systems where memory is limited. Interpreting data in multiple ways. So same bytes can be accessed as int, float, or char at one at a time. Variant records, the example of employee, okay. Then device drivers and hardware communication. Unions help in mapping registers with the bit field, registers the memory, okay. Protocol handling, data packets vary. Unions store different packet formats. And type pruning, accessing same memory as different types. Okay, that actually is known as a type pruning, right? Fine. Is this clear, everyone? Just give me a minute. Okay, I hope this is clear to everyone. Union and structure now understood the difference between these two, the memory allocation, the memory management, everything. Yes. Can I get the confirmation on this, everyone, so that we can go ahead to the next topic? Yeah, is this understood? Okay, fine. Jyoti, okay. Okay, fine. So this is very important. Understand structure and union both, okay, for creating the user-defined data type, okay? Now, let us come to very important topic again, okay, which is file handling, okay, file handling. Okay, so what we are going to, go through in the file handling, different file types, file opening modes, character, string, formatted, and binary input output, handling structure records in binary files, random access files, and command line file operations. Okay, very important topic again. Okay, so let us start with the files. Okay, now see, till now what we did, okay, till now, okay, from the beginning, okay, we are writing the programs, we are compiling, we are getting the output on the console. Okay, now every time when you want to see the output of any program, you need to execute that. Okay, so instead of that, okay, if this particular output you want to, write to a file so that it is persisted. Okay, so persistence means that saving or storing somewhere. Okay, so in that case, we will be writing this to the files. Okay, to the files. So file is a collection of data stored on a disk. Okay, file is a collection of data stored on a disk. Now, what are the benefits of using files? Data persists even after program termination. Okay, so whatever is the output of the program that is there in the file, which is persisted, which is stored permanently. Okay, you don't have to then, again execute, because your console is going to get terminated after the program execution. Large data can be stored, easy to transfer and process, useful for logs, databases, configuration, okay, where you need to write configuration information, you need to store the log information of the application or of the system, or you want to perform the CRUD operations for database, okay. Now, if you see this particular diagram, okay, registers, see, these are all, okay, where your data is going to be stored, right? Registers, then we have got cache, then we have got RAM. Okay, registers, data which is written on the register or stored on the register are quickly accessible, okay, for processing. Then comes your L1, L2 cache. Okay, then you will be having the random access memory, and then you are having the hard disk, correct? Now, this side is volatile. Volatile means, okay, this particular data which is there on the register or cache is going to terminate. Okay, but the hard disk data is non-volatile because this is going to permanently store the data. Okay, so now what we have to learn in file handling is how you will be writing these data, okay, to the files, okay, which is non-volatile, right? So this is nothing but a memory hierarchy, okay, of a system. Now coming to what are the different types of the files which are getting created or which can be created. Okay, so we have got the text files, data stored in human readable ASCII characters. I don't have to tell you about the ASCII. We already understood this in the previous sessions. Okay, all the characters, okay, from A to Z, or it is small, or every particular character on the keyboard has got these ASCII characters. Okay, American Standard Code for Information Interchange, right? Now, when the data is written, okay, in the text file, which is in a readable format, so data will be like this, like hello user, the numbers will be written like this, and this is readable, okay. Then there is a binary files. Now the binary files, your data is not written in the human readable characters. So it is going to be written in zeros and ones, and you will not be able to read this particular file. Okay. More compact and faster, efficient for structures. Now that we have understood already, okay, what is the primitive type, how you're going to initialize or access that, what is the structure, okay, how the structures will be initialized and accessed, everything is done. Okay, now when we need to write the structure information, it is always better to make use of binary, okay, because this is more efficient and this is useful for writing and reading the structures. Okay, so first is, okay, understand that there is a text file, human readable characters will be read, okay, and there is a binary file, okay, in which the data is going to be written in zeros and ones, okay, that is binary. Fine. Now coming to your find handling basics. Okay, now how you will handle this reading and writing. Okay, now C uses a structure. Okay, file pointer. Okay, now there is a file which has to be actually written in caps. Okay, so we are going to create a pointer to that file. Okay, so file pointer is created. Yes, we are going to make use of the standard your stdio.h. Okay, now opening a file. To open a file, there is the fopen function available. Fopen. Okay, file open. Now, how you will be writing that? Okay, so file pointer is equal to fopen data.txt. Okay, this is the first parameter to the fopen. Now, second parameter is nothing but the mode of file. Okay, now what is the common modes of the file mentioned here? Okay, so R is for reading. That means you want to open this file for reading. Okay, then if you are writing W, that means you want to open this file for writing. Okay, create or write. Now, what will happen? Understand, there may be two conditions here. Now, if you want to write something in the data.txt and this file does not exist, then this file will get created by the operating system and the data is going to be written to this file. Okay, if data.txt already exist, okay, then the contents are going to be overwritten if you're going to write W. Now, if you don't want the contents to be overwritten, but the contents should be appended, then you will be writing A. Then you will be writing A here. So remember, either you are going to open the file for reading or writing. Okay, that is the mode here. Now, if you are using R plus, means you are going to open the file for read plus write, W plus read plus write overwrite, then A plus read plus write append. Okay, that means you are going to open this file for reading as well as the writing purpose, right? Then RB, WB, AB, this is same for binary. Okay, so read binary, write binary and append, correct? So this is for binary. Now, this is the mode of opening the file. That is the second parameter given. Okay. Now, after you will read and write from the files, then you need to close the file. Okay. So, wherein the underlining stream, understand how the data is written, it will be written in bytes only, right? It is a stream of bytes, which is going from source to destination. Now, when the reading and writing is done, okay, it is not directly done or written to the hard disk. There is a concept known as a buffer. Okay, so we will see this in the next this particular slide. Okay, so F close this particular pointer, file pointer. Now this is going to close the underlining stream or the resources which are opened for reading or writing. Okay, so this file pointer needs to be closed. Now, these are the basics. Okay, opening a file, okay, use a file pointer, and closing a file, you're going to make use of fclose. Okay, and these are the common modes of opening the file. Okay, this needs to be understood, right? Now, let us understand that what is a buffer and how this works. Okay, so what I said that directly it is not written. Okay, it is written through the buffers. Okay, now this is very important concept again. So when a file is opened using functions like fopen, C does not directly read from or write to the disk using fgetC, fputC, fprintf, etc. Okay. See, we have used the printf function. Always we have used the printf function. Printf is going to print the output onto the console. Fprintf file. Okay. So this is going to write onto the file. So reading is what input and writing is what output. Okay, write means you want to write to the file. So printf is writing to the console. Fprintf is going to write to the file. That is the difference. Okay. FputC, that is putC is what? Character writing. So it is going to write the character to the file. FgetC, this is going to read a character from the file. Okay, so it is not directly reading from or writing to the disk. So how it is done? Okay, what C uses is known as a buffer, which is a temporary area in memory. So if you come back to this diagram, okay, we have got RAM, okay, and then it will be written to the hard disk. Now RAM will have a temporary storage, which is known as a buffer. So your data first will be in the buffer, then from the buffer, it will be returned to this particular hard disk. Okay, in a file, correct? Now, how this is done, right? So a file buffer is a block of memory where data is temporarily stored before being written to or read from the file. Okay, so now because it is both way, understand, you need to read also, you need to write as well. Okay, so this is your program, right? Now if in this program you have implemented the writing and the reading, then first of all it is going to be in the buffer, which is a temporary area, okay, in memory, and from there it will be written to the file, and for reading purpose, first it will be read from the file, it will be stored in the buffer, and then okay, it is going to be given onto the console. Okay, so this is how it is working. Okay, this is the first point. Now when you are going to make use of buffer, okay, what are the benefits? Reduces the number of disk accesses. Disk operations are very slow. Understand? If one by one byte is directly going to be written to the actual file on the disk, okay, with every read and write operation, understand, with every read and write operations of the byte, there is the operating system function being called, correct? Now instead of that, the buffer is going to have a block of data, a block of memory, okay, like 4 KB in most of the system. Now this can vary depending on the operating system and depending on the type. Okay, so instead of writing one by one byte directly onto this file, buffer will be having a 4 KB block. Now that 4 KB, which is 4096 bytes, that will be at a time written to the disk. Okay, so so now understand the operating system. Okay, that particular function for every byte is not going to be called. So this is actually more efficient. Okay, improves the file input output performance, allows efficient reading and writing. Now every file pointer created by the fopen has an associated internal buffer managed by the C standard library. Okay, so it is internal buffer. It will be there when you are using the fopen function. So your data is going to be written into the buffer. Okay, now let us understand this with one example. Okay. So now there are different types of buffering also available. Okay. So if you are using the fully buffered, okay, if you are using fully buffered disk files, okay, now what are the extensions of the file? It may be a txt file, it may be a binary file. So data is stored in buffer until full, then return. Okay, so what will happen in the case of fully buffered? Now your buffer is full. Okay, if 4 KB size is there, 4 KB, that much size, your buffer is full. Now when the buffer is full, okay, then the contents of that buffer will be returned to the file. Okay, it will be returned to the file. That is the first. Then there is a line buffered. Okay, terminal IO, standard in, standard out. Flushes buffer when a new line or slash n occurs. Okay, so when you are making use of the terminal IO, slash n, okay, it is going to be written to the console. Okay, unbuffered, okay, that is a standard error, right? Output goes immediately to screen, used for errors. We are going to do this error handling in the tomorrow session. Okay, so in that we will understand how you are going to handle the errors in the file as well, and what are the common error handling techniques available, okay, in any particular program, right? So we have got the standard in for input, standard out for giving the output, and standard error, okay, which is unbuffered. This is also going to the output, okay, if there is an error, right? Now let us understand the working of buffering. Okay, now this is simple example. Okay, so there is the f put c. Put c means what? This character. Okay, now what is a file pointer? Understand the second parameter is a file pointer, because file pointer points to the file in which you want to write something. Okay, this file pointer is pointing to data.txt. Okay, as an example. So when you are using f put c a fp, which is pointing to data.txt, so this a should be written to data.txt. Okay, then you need to write b to data.txt, c to data.txt. Okay, so here character by character we are writing, correct? Now program writes abc, goes into file buffer ram. So first it is going to get into the buffer. When buffer is full or file closes, when you are going to make use of f close method, then data is written to the disk. Okay, so either when the buffer is full or when you are using the close method, then the data is written to the disk, okay, through that buffer. Similarly, now let us say that you want to perform a read operation. Okay, so you are going to use f get c file pointer. Okay, file pointer is pointing to data.txt. That means you want to read the character from data.txt and you want to store that in this variable ch. Okay, now what happened? Disk loads block. Understand? I'm talking about the block now, because your buffer will be storing the data in the blocks. Okay, so example is 4 KB. So usually what happen in the system like Linux and Windows, the buffer size will be 4 KB. That is nothing but 4096 bytes. Okay, so in Windows it may be 4 KB or 8 KB. In embedded system, this is 128 to 512 bytes. Okay, and in the network streams, it may be 1 KB to 16 KB like that. Okay, so here example 4 KB. Okay, now this will be loaded. Okay, then f get c gets character from buffer one by one. So from the hard disk, it will be loaded to the buffer, and then your program is going to read one by one, okay, character from the buffer. Now this is how it works. Okay, the working of the file is important to understand what is buffering, how the buffering works. Okay, so it is done through buffering, right? Now the question is that when the buffer is going to flush, understand, whenever, okay, whether you are using C or you're going to make use of any other particular technology like Java, .NET, wherever you are going to make use of reading and writing, and whenever the writing has to be done, there is a concept of flush. Okay, there is a flush method also available. Now, flush means writing the data completely to the destination. Okay, flushing the data in the buffer to the destination to be written. Okay, so this will happen when you're going to make use of the F close file pointer. Okay, so your data in the buffer is going to be completely written to the destination. F flush, there is a flush method available, forces the buffer to immediately write to the disk. Okay, so the F flush method is going to force the buffer to immediately write to the disk. Okay, buffer becomes full, or when the buffer is full, okay, then it is going to be written to the destination. Program ends normally. File switches from read to write mode. Okay, so there is a reading and then writing is happening. Then it is going to flush the contents. New line plus line buffering, which is a standard out. Okay, so this is a simple example I have written. Okay, so there is a user program. Okay, now user program is writing the F put CA, then F put CB. Okay, now this is going to be written to the file buffer, which is RAM. So A and B is written. Now after that, there is an empty, okay, buffer, because only A and B is written. So flushed to disk later. Okay, and similarly, when you are going to read, so let us say disk file is 50 KB data. Okay, so C library reads block 4 KB buffer. Okay, at a time, because 4 KB is the size of the buffer. So program reads 1 character at a time. Okay, now this is how the buffer works in C. Okay, this is the full concept behind the file read and write. Okay, so now what I'm going to do first is we will create a simple program to understand the basics. Okay, so I will be closing this, right? And let us start writing a new file. These are the files which I will be going through later. Okay, so first of all, we are going to make use of the stdio.h. Okay, then I will open the main function. So these are the file functions, okay, basic file functions. Okay, so let us now save this. So I have created the day12. Okay, so basic file IO. Okay, so now here, what we will be using, first of all, you need to use a file, okay, file structure, and this you need to create a pointer to the file is equal to F open. Okay, now F open. So first you are going to make use of the file name, and second parameter is the mode. Okay, that is what we have understood. So here, let us say I'm simply going to write the sample.txt. I want to open the sample.txt and we are going to write. Okay, now one more thing, remember here, if you don't give the path, okay, where this file should be created, this file will get created in the same folder. Okay, so we have got this C program state well, the file is going to be created in the same folder. Okay, so W means I want to open this file for writing purpose. Okay, what I told earlier, file will get created. Okay, file will get created if not exist. Okay, if the file is not there, this will get created, and W means the contents are going to be overwritten. Okay, so you can write A. Now if the file pointer, always you need to check the condition. If file pointer equal to null, null means okay, it is not pointing okay to the file, or there is an some exception occurred, or the file is not being opened. So you're going to write here printf, okay, file cannot be opened if it is null. If it is not null means it is pointing to that particular file. Okay, so file cannot be opened. Okay, so we can give this message to the user. And we are going to return 1. Return 1 means it is not successful. Understand, we are always writing return 0, okay, which is C successful. okay, termination of the program. Okay, but if otherwise, what should happen? So printf, I'm simply going to write file opened, okay, successfully. This is simply opening the file. Understand? We are not writing anything as of now. I'm just going to the basic functions which is required. Now, f close, okay, you have to use the file pointer because fp is used to open the sample.txt. So fp is pointing to sample.txt. When you're going to close, this is going to release, okay, releases the resources and flushes the buffer. Okay, so we have now talked about the buffer, okay, what it is and how it is working. Okay, so f close fp, it releases the resources and flushes the buffer. Okay, and this is going to return 0 if successful, right? So this is basic file IO. Now let us go to the day 12. Okay, and we will go for the basic file IO. Okay, fine. So what I'm getting, understand, I'm getting file opened successfully. We are not writing anything. Okay, but we have to simply check whether file is created or not. Okay, so if you go to this 12, day 12, so you can see this sample txt file is getting created. Okay, but this is an empty file. Okay, this is an empty file because nothing is written in this file as of now, correct? And one more thing, if you want to create this file, okay, somewhere else, then you can write like, you know, d colon, it should get created in d colon in some folder, like this path you can give. But if you don't give the path, this is going to be created in the same folder where you have written this particular program. Okay. So this is a simple code to understand what is the fopen function. Okay, what is the fclose? Okay, and this is what we are going to use henceforth in all the other programs. Okay. Is this basic file opening is understood by everyone? Is this understood? Okay. Any questions in this? Okay, Jyoti. Fine. Okay, so now this is quite, easy to understand this way. Okay, if you will go just for understanding first the basic functions. Okay, now let us go to the next topic. Okay, now that we have understood about what is opening and closing of the file, now we will understand the different types of reading and writing. Okay, so we have got character reading and writing, string reading and writing, formatted reading and writing, and binary. Okay, input output. So these are different types of the input and output or reading and writing to the files. Okay, so input is reading, output is writing. Okay, now first we will see the character. Okay, so one by one example we will do. First is the character IO function. Now, the purpose is what? Reads one character from a file, writes one character to a file. Okay, so what is the function we are going to use? F get C, and this is F put C. Okay, so reads one character from a file, writes one character to a file. Then header file is stdio.h. Okay, syntax is, now understand here. So we have got F get C file pointer. Now we understood what is file pointer. Here you are actually giving the file. Okay, the return type is integer. Here also F put C, what is the character you want to write, and second is your file pointer. Okay, what character you want to write, and second is the file pointer. Return value, return scan, ASCII or end of file. Now EOF in file means end of file. Okay, so you need to read okay, from a file till it reaches end of file. Returns return character or end of file. Now file mode needed. Now get C means you want to read, correct? So either you can make use of R, you can make use of R plus or A plus. Okay, write WA, this is write all. Okay, plus means write. Use case, reading file char by char, writing characters, useful for loops until end of file, write single characters only. Okay. So this is what is the use case of the character IO function. It is going to read and write character by character. Okay. So let us do one example based on that. Okay. So I'm going to open another file. So this will be the character reading. Okay. And I'm going to make use of the functions also. I will not write everything in the main. Okay. So let us save this file as character input output.c. Okay. So what you have to do, please understand. So first I will be creating the functions. Okay. So let us say this function is void write characters. Okay. Write characters. And here I will be writing the code for writing. Okay. To the file. And let us create this as read characters. Okay. And here you are going to write the code for reading. Okay. Then we will be writing the main function and you call both the functions from the main. This is how you should write. Don't include everything in the main function. Okay. So first I'm going to call the write characters. Then I will be calling the read characters. That's it. Okay. Make it modular. Now, first of all, we will write, okay, to the file. So what I will do, we will make use of a for each loop, okay. So I'm going to use the file pointer is equal to f open, okay. So I will create a file as character file .txt if it is not, okay. And if you want, I can now use A is for append, okay. Now next is I will use a loop to write all the characters. Okay, so we have already done this earlier. I'm doing it again. I is equal to, I need to start writing from A. Then I is less than equal to Z. We know it is going to make use of ASCII characters. Okay, then we will be using the F put C. Okay, what is I and what is the file pointer? So that means you need to write this all character one by one to the file which is pointed by the FP, that is the character file.txt. Okay, so this is going to write character by character, okay, to the file character file.txt, right? Now, after this, okay, after the writing is done, the next step, what you need to do is you need to close. Okay, so F close the file. Okay, this is how you should write. Now you want to read. Okay. So for read also, we are going to use the same thing. Okay, so I will be copying this. The only thing is our reading needs to be done. Okay, so file pointer is correct. It should open this particular file. Okay, and then I'll be creating int character, which is going to read. Now, how you're going to read? Use a loop. So while ch, understand ch. Okay, please go through this reading. Okay, so we have got f get c. So we are going to make use of get c. Okay, so ch equal to f get c file pointer. Okay, so this is going to return what? Integer. Okay, so we are anyways using this character as integer because we are using ASCII character. Okay, so f get c file pointer is not reaching end of file. So this EOF needs to be used. Now what you need to do? Okay, you need to put char, okay, ch. Okay, put char ch and f close fp. That's it. Okay, this is your code. So first is writing to the file and then reading to the file. Okay. So before this, if you want, I can give some printf statement. Okay, so I can use here percentage S. Okay, so I simply want to give, okay, data written to the file. Okay. Now, let us execute this. Okay. So we are having this file as character io.c. Okay. Right. So I think there is something missing here. This is correct. This is A. Then int I am going to open for I is equal to A. I is less than equal to Z. I plus plus. Then F put C. I and FP. What is the error here? Is this, it is closed, correct? Hash include stdio.h. There may be some closing error. FP is equal to F open. Line number 6. Oh, sorry, semicolon. Okay, not comma. Okay, so let us now check, right? So what I'm getting, data returned to the file. Okay, I'm getting data returned to the file. Okay, so let us check. So first we will see here, the character file is written. Okay, so if you double click on this now, all characters from A to Z is written. Okay, all the characters from A to Z is written. Okay. Once again, if I'm going to execute, it should get append data. So let us check once again. So if I'm going to use A, okay, data returned to the file. So see, it is appended. Okay. Why? Because we have used A, right? We have used A. Now, let me just go ahead and write here, okay, to the, so I'm just going to make use of printf. Okay, so we'll have the percentage. Okay, and let us write this ch. Okay, so if I'm not calling the right character, so in this case, you can go on commenting and then, okay, execute that because the writing is already done. But if you want to call both, then you can call the both functions. Okay, so that is up to you how you want to call it. Okay. Yes, Naimish. This should print to console, right? Why it is not printing to console? Maybe I've not written this, but it should print the characters to the console because put char is written here, correct? Um, is not equal to end of file put char. This should also print, okay? So it is not getting in this character file. Oh, I have to open this in reading. Sorry, okay, that is why it was not printing. I copy pasted it, so we need to open this in the reading. Okay, so now it is being read. Okay, so what I'm going to do now, let us call this both. Okay, and one more thing. So let us say that I'm calling the read character, but this file is a different file. Okay, so I'm using character file 1.txt. Okay, character file 1.txt. Now this file does not exist. Okay, so what will happen if the file does not exist for reading and writing? Okay, so let us go for A. Okay, so there is no output in this case. Okay, so I'm just calling the read characters, but we need to check that. Okay, that error handling will be doing. So now what I will do, I will perform this write and read both. Okay, and I will be deleting the contents. Okay, from this. Let us delete. Okay, let us write and read both at once. Okay, so I will be going through. So I'm getting data returned to the file, and this particular data is actually being read from the file. Okay, so if you go to character file, this data is being written to the file. Now, if you see, this is return, which is human readable. Okay, and this data has been written character by character. Okay, character by character. So this is first. Okay, this is one, right? So you can write the character by character in this. Okay, what you need to remember is what are the functions you are going to make use of. Okay, now the next is, okay, next is your string IO functions. Okay, string IO functions. Now the way the characters are written, here the string is going to be written. Okay, so purpose is reads a line or string from a file, that is f get s. S is a string. Okay, file put s, f put s, so it writes a string to the file. Syntax is, okay, you are going to make use of this f get s, char, whatever you want to write to. Okay, and int n, number, file, pointer. Okay, so this is the parameters. Okay, this is the parameters, right? How many characters you want to write, and the pointer, which will be pointing to the file. Similarly, when you go with the put s, sorry, this is for reading, this is for writing. So this is the constant char star, that is the string which you want to write, and the pointer. That's it. Okay. Return value returns pointer to string or null. Okay, if it contains the data, otherwise it will return null. Returns non-negative values on success. Reads until new line or n minus 1 chars or end of file. Okay, till it is reaching new line or n minus 1 characters. N is what the number, or end of file. When it will be writing entire string until /0. Okay, /0 is the terminator. Auto add /0, yes. Okay, no string must contain /0. Includes new line, yes. No, only writes characters in the string. Use case reading lines from text file, writing text or logs into the file. Okay, now this is the string. So what we will do now, let us create a string. Okay, so I'll copy this. We are going to make use of the functions only, but I will be not using this. Okay, opening and closing the file is going to be same. Correct? Here I will be using the function write string. Okay, so don't write again and again. Here I will be writing read string. Okay, this will be read string. And here we will be calling write string. Okay, and this will be read string, right? And let us save this first of all. So this is going to be the what string IO. So let us save this as string IO.c. Okay, and now we will be changing the file name. Okay, so accordingly, I'm going to create the file. So this is a string file, and here also we are going to read the string file. Okay, fine. So this is going to be same. Remember, this is going to be same. So what we are going to change only the contents in this. Correct. So write string. I'm just going to write f put s. Okay. So this is example of what? String I. Okay, I just want to write this particular statement. Yes, you can take the input from the user and you can write that. Okay, and file pointer. Okay, that's it, right? And when you're going to read, so here what I'm going to use, I will be creating the number of characters to be read. So char str, let us say 50 I'm giving. Okay, now f get s. Okay, understand the parameters of the f get s function here. Okay, so this is reading, right? F get s. Okay, char str, then int n, then the file pointer. Okay, so here we are going to make use of the str. Okay, that is what is the character we created, the array. Number we have given is 50. Okay, and the file pointer is f. Okay, and whatever is now being read, okay, that we are going to print. Okay, so we are going to make use of printf. Let me just write here read string is okay percentage s, and then we can make use of the str because in this we have got the data, okay, from this particular file. Okay, so this fp is pointing to the string file.txt for reading purpose, and whatever is being read, okay, by using this it will be stored in the string. Okay, and we want to print that particular data. Okay, so let us check whether we are getting this or not in the string file, and this should got created. Okay, so let us go for string io.c. Okay, so look here. So I'm getting the red string is, this is example of string io. Let us check whether the file is getting created here. Okay, so we have got the string file created. Okay, so you see here, this is example of string io. Okay, we are getting that, right? So, okay, now I'm getting this twice because it is appending. So let us check how the data is written to the file now. So if you go to string file, here, okay. So this is what is a string IO function. Okay, now let us go to the next, which is formatted IO functions. Okay. So basically, this is going to make use of fprintf and fscanf. Okay, so purpose writes formatted output to a file and reads formatted input from a file. Syntax is given: int fprintf, file pointer, constant char format. Again, in the scanf, you're going to use the file pointer and the format. Works like printf, but to file. Scanf, but from file. Returns number of items written, and scanf means number of items read. Use case: writing structured logs, numbers, strings. Reading structured data from text file. Constraints: output becomes the text only, okay, because you will be using the format, okay, specific format to output, and reading fails if the formatting differs, okay. So this is the formatted IO function, okay. So let us write one code for the format IO. So again, here I will be using stdio.h, okay, int main. So first of all, we will be creating a file pointer. Let us say now we will include multiple, okay, the student information. So let us say I'm writing 101. Okay, float. Let us say we are writing some marks. Okay. Then we will be having the name. Okay, so let us say this is a name with 20 characters written. And this name, I'm just going to have student 1. Okay. So let first save this as format io.c. Now, let us open the file. So fp is equal to f open. Okay, and this is student. So I can use the student.txt here. And this is for writing purpose. Okay, so I'm going to make use of write. Okay, now we will be writing the formatted data. Okay, formatted data. Okay, go on saving. So f print f. Okay, f print f function you're going to make use of. First is your file pointer. It is pointing to student.txt. Then I will be writing like this. Okay, so let us say roll number. Okay, %d /n. Okay, name. Okay, which will be %s. Then /n marks. Okay, which will be %.2f because it is a float. /n, and then I want to give the what role. Okay, then we have got name and then the marks. Okay, so this is the 3 parameters. Okay, and then you are going to close. Okay, use the f close with the pointer, that is a fp. Okay, so this is writing done. What we can do here, I can specify just one printf statement. Okay, if you want to give a message to the user. Okay, so data written to the file. Okay, or data successfully written to the file, right? Now reading the formatted data. Okay, so reading the formatted data. Now here fp is equal to f open. Okay, student.txt, and here I'm going to use the read. Okay, because we need to change this mode, otherwise you will not get the output. Now you can also check the condition like this: if fp is equal to null. Okay, Null means it is not pointing, it is pointing to null. So the file is not available. So we can give a printf. Similarly, you can do this with the with write also. Okay. So printf error opening the file. Okay, error opening the file for reading. Okay. Return 1. Now, if the error is there, then we are going to get this. Else, okay, what you will be doing? Now you create these variables. Okay, so int roll number. Okay, float marks. Okay, so let us say I'm just giving this MRKS as marks and then char name. Okay, so let us say I'm giving the name as this. This is 20. Now we have to read and we have to store in these variables. Okay, so now what we will be doing is F scan F. Okay, F scan F, right? File pointer, it is pointing to student. Okay, now the same I'm going to give. Okay, roll number. Okay, percentage D slash N, the address of roll number. Okay, because we are reading, right? So use the address now because this is scanf. Similarly, I'm going to make use of the other two. Okay, so let us write here. This is a name. Okay, so this will be S and address of NM. That is nothing but a name. And similarly, we'll be taking for the marks. Okay, so here I'm going to write marks. This is percentage dot to F. Okay, percentage F. And this will be address of marks. Okay, that we have read this data from the file. Now we can print. Okay, so this is to display the data. Okay, so now I will use the printf statement because we need to give this to the console. Okay, so this is the student details, okay, which we are reading from the file. And now you can print this the way you want. Okay, so I can give like this roll number percentage D slash N, and this is going to be the roll number, what I have written here. Okay, fine. Vinutna, let me just complete this. Okay, we are going to display. Okay, so I'm going to first compile this. Anyways, I will be sharing, okay, all these particular files. Okay, so you can get it. Name. So let us display the student name. Okay, so this will be percentage S. And here I've given the variable as NM. Okay. Then we need to display the marks. Okay. So here this will be dot to F. And what variable we created? MRAS. Okay. Fine. So this is return 0. I have written now, see everything in the main. Okay. Later on, we can write this in the functions as well. Okay. So let us check now. So this needs to be the format io.c, right? So gcc. Okay. Data returned to the file. Okay. Marks. Okay, let us use a /n here, otherwise we are not getting the correct output. Okay, so let me first check what is written. So there is a student.txt created. Okay, so we have got roll number, name and marks. Okay, see, it is written in this particular format. Okay, roll number, name and the marks. So marks is not being read properly. Okay, let us check. Maybe I have not. Okay, so marks is going to F printf. Then this is correct. Roll number, marks. Okay, so roll number, name and marks. The contents are going to be overwritten because I'm using W here. Okay. Now it is written. Okay. Student details. After this also I need to use /n. Then only you will be able to read the data properly. Now marks are being read. Okay. See, it should be reading and writing format should be same. Otherwise, then you will not be able to get the data. Okay. So my format was not correct earlier. So I'm getting now the data being read, and how the data has been written. If you will see, okay, here, okay, how we have written the data. Okay. So we are using /n, okay, roll number, name. The same way the data is being written. Okay. So you can see here, this is how the data is written. Now it is not appended. Okay. Because we are using W, which is going to overwrite. Okay. Fine. Okay. So let me just check. Yes, Vinutna, today is a quiz. Okay. Fine. Now let us go to the next. Okay, which is nothing but binary IO function. See, binary is very, very important. Okay. Purpose is it reads raw binary data. Okay, F read reads raw binary data. F write writes raw binary data. Syntax is given. Okay, size underscore T, which is predefined. F read void pointer, then size, then count, and then the file pointer. Okay, similarly, if you go with the write, there is a pointer, then the size, count, and the void pointer, and then at the end you are having the file pointer. Okay. Return value is number of items read. Write is number of items written. Use case reading structures, arrays, binary data. F write writing structures, files, and records. Speed is faster because no formatting is done. F write faster, no formatting. Use cases, databases, images, and records. Now, why this is more efficient? Because it is reading and writing the data in binary, which is not the human readable characters. Okay. This is usually used in the structures. We already did the structures. Okay. And the databases, your images, okay, records, okay, all these are going to be stored in the binary. Okay, that is very beneficial. Okay, but there are certain points to remember when you are using a binary input output. Because we are using structure in binary. Okay, please understand we are using the structure in binary. Okay, so when you are using the structure in binary, okay, and we know the structure is making use of the padding. Okay, the alignment, the data is, I mean, the size will be different. Okay, on the different architectures or the operating system. This needs to be considered. Okay, now this is a very important concept. First of all, use size of struct consistently. Don't use the hard-coded values in finding out the size of a structure. If you have created a structure as employee, so use the size structure of employee rather than giving the size of a hard-coded value. Okay. So do not write hard code values in size of. Different machines may align structures differently, different sizes. We have already understood this. You can change the order of the members, okay, in the structure, which is anyways going to change the overall size, the alignment, okay, of the data in the memory. Okay, so you have to always use size of structure and do not use the size of the hard coded values. Okay, that is first thing. Avoid padding issues. Padding must match between reading and writing values. So keep structure layout same in both write and read programs, or disable padding. We had done this yesterday. How to disable the padding, how to disable that space. Okay, so hash pragma pack 1. Do not write pointer member inside the structure. Pointer stores addresses and not data. So after reading back, pointers will be invalid. Okay, so better is store data inside arrays and not pointers. See why this considerations? Because now you are reading and writing structures to the file. Okay, open files in binary modes only. So we have got the binary modes available. Read and write same number of records, and do not mix text and binary modes. Okay. Structure must not contain dynamic arrays. Not safe. Like you are writing int add and you are not specifying the size, or it is not initialized. Don't use the dynamic arrays. Okay. So flexible array member are not suitable for binary files. Okay. And one more important consideration is endianness differences. Different CPUs stores integers in different byte codes. Okay, now there are two ways available. Little endian is available, okay, and your big endian is available, okay. Binary files written on one architecture may not work on another. Now for this, avoid cross-platform binary file sharing or define own byte order conversion. Okay, avoid cross-platform binary file sharing. Use the same binary file for reading and writing on the same platform, because the exe created, okay, for one particular processor platform is going to be different than the other. Please understand, the endianness, okay, is going to be different in different operating system. Okay, we will first understand this. Endianness is a byte ordering rule that defines how a multi-byte value like int, float, long, double is stored in computer memory. It decides which byte comes first, most significant or least significant, which when storing data in RAM or writing to a binary file. Okay, now what is this endianness? There are two. We have got little and big. Okay, now in the case of little, least significant byte, which is known as LSB, is stored at the lowest memory address. The byte order is reversed. And in the case of big, most significant byte stored at lowest memory address. Now, this is going to be appearing natural. It is left to right. Okay, to make you understand this, there is the example, let us say int x, which has got this value. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Correct? This is hexadecimal. Now, if you go for the little endian, okay, these are the memory addresses written. Example 1000, 101, 102, and 1003. Okay, sample address. Now, in this case, if you will see, the least significant bit, which is 78, is stored first. Okay, least significant bit is stored first, and most significant bit is here. Okay, so 78 and 12, it is reverse order. So this is stored in the reverse order. Okay, so LSB 78 stored first. Okay, and in the big Indian, so here if you will see the 1000 contains 12. Okay, so MSB stored first. Okay, most significant is stored first. So this is the natural, you can say the ordering which is left to right. Okay, so if you go to the this particular different systems, okay, like little Indian will be used by AMD processors or Intel, okay, and big Indian can be used by the ARM, which is configurable networking standard, or the other Motorola processes. Okay, so this is going to be different. Now, based on this, your structure depends. Okay, so it is very important that this should be maintained. Okay, now let us do the last program here for binary input output. Okay, so what I'm going to do, let us copy this again. Okay, and I'm going to paste this here for binary. We are going to read and write the structure. Okay, so this is binary IO. Okay, this is binary IO, right? Now here we are going to write a structure. Okay, so first of all, what I'm going to do, I'm going to create a struct student. Okay, so again, I'm taking the student example, right? And then we are going to write here the int roll number. Okay, char student name. Okay, and these points you need to remember. Okay, whenever you are writing this. So this is the marks, correct? Now we will change the function names. Okay, so I'm going to have binary. This is read binary. Okay, this is going to change. So this is also going to change. And here I'm going to call the function write binary. Okay, and this is going to be read binary. Okay, simple. Now change the file name. So when we are going to make use of this binary, okay, I'm going to use not the txt file. See, there is a data file available. Okay, so what I can do, I can write the student.date. That is a data file. Okay, and here also I'm writing the student dot, and you can open this in the notepad, okay, to see the data, but it is in binary. Okay, so now understand, whenever you need to read and write structure, use binary. Okay, use binary. Today is the assignment, today is the quiz. Okay, yeah, so after this you will get that. Now let us write here. So we have got the student. Okay, fine. So we can have to write the structure. So struct student S is equal to initialize. You can initialize like this also. Okay, this we did. So we have got student 1. Okay, let us write some marks here. Okay. File pointer already created. Now simply you have to use the F write. Address of S. What you need to write? Size of S. Okay, that is your structure. How many one structure value you need to write, and file pointer. Okay, that is how you need to understand the different parameters here. Please understand. Address of S is the pointer to the data to write. Size is the size in bytes of each element. That is size of the entire structure. It depends because padding is also used. 1 is a number of elements to write, and FP is the file pointer. Okay, that's it. So your data will be written in binary in the file student.dat, and in the read binary, you are going to use the struct student. So just create student S. Again, I'm creating. Okay, now F read. Okay, now use the F read method. F read address of S. size of S, that is size of your structure. That is why it is said that use the reading and writing on the same system and do not use in the another system, because the Indianness, okay, will differ how the bytes are written. Okay, it may be little or it may be big. Okay, so reading is not going to give you the proper output. Okay, so one element and the file pointer, and finally what you do is you simply print the output. Okay, so I want to give the roll number, %D, name, %S, okay, marks, %.2F. Okay, and I want to now use this S dot roll number, S dot name is what? S name. Okay, and then we have got the marks. Okay, and then you have to close the pointer. Okay, so this is binary IO. Okay, so write binary and read binary. Okay, just make the changes here, huh? Otherwise it will not be. Let me check. What is the error? Oh, capital. Somewhere I have written this. It is case sensitive. Okay, so see here, roll number 101, name student 1, marks 95.50. Now, when you are reading this binary, okay, and you are displaying the values, you are getting this in the proper format. But now, if you will see the student.dat file, this is the data file. Okay, you can open this in the notepad. And this is how it is written. This is not human readable. This is written in binary format. Okay, you will not be able to see the data correctly. Okay, so if I will open this in the notepad, okay, see, this is how it is written. Okay, student 1, but then it is written in binary. So this is not readable. Okay, but when you are going to read it, okay, so it will be read properly and displayed. But because of the factors, whatever I have told you, reading and writing, do it in the same system. Okay, otherwise, it is not going to give you the correct output. Okay. Finally, this is the tabular format given for all whatever we have done. Character IO. Okay, reading one character, writing one character. String IO, reading the string, writing the string. Formatted IO, reading and writing the formatted data. And binary IO, reading the binary block. Okay. Fine. So this is your file reading and writing. Yeah, command line and random access is remaining, that we can do tomorrow. Okay. Shushmita, you can share the quiz link now, last 10 minutes. Vinutna, I will share these files. Okay.
I'm sharing right now, ma'am.
Yeah, yeah. Everyone, again, please give the quiz. Okay, only 10 questions. And once submitted, okay, let me know. Yeah, quiz is shared. Okay, this is quiz 4. Okay, only 10 minutes you will get. Last 10 minutes. Okay. Ashwini, quiz link is given. Quiz link is given in the chat itself. Ashwini, you can get it from there. Foundations of Programming using C quiz 4. Link is given in the chat. Okay, for everyone. Oh, chat box was not open, Shushmita, today, I guess, right? Initially.
Starting there was it's not open, ma'am, but now there is no
Okay,
issues.
okay, fine. So Naimish, it will be opened. Okay, today maybe it was not. Okay, later it got active. Namira, link is shared. Shushmita, you can share the link again of the quiz. Some of them are not able to find the link. So quiz link is shared again. Ashwini, okay, if you have not, please get, or Namira, you have not received the link earlier, you can check now. Okay, Veni, you completed test. Good. Varsha, okay. Sai, attendance link is shared already. Please check. Shushmita, you can share the attendance link. It is shared in the chat. Kaustav, okay, you completed the test. Okay, Chetan. Okay, Lina. Okay, Shreya. Prerna, you have done. Prakash, completed. Akshara, Jhansi Devi, okay. Okay, so both of you completed, right? Lakshmi, Sharda. Okay. Sharan Sai, Kumar, completed. Namira, good. Hasini, completed. Okay, Vinutna, Ganeshwari, Gautam, Pratipati completed. Shushmita, how much more time we need to give them? 2 minutes? Then we can close.
Yeah, sure, ma'am.
Yeah.
No issues.
See, this session is going to be till Friday, okay? So tomorrow again this 10 question quiz will be there, and Friday we'll be having the last quiz, okay? Assignment. Okay. So I think Shushmita, we can stop now, okay? The quiz, I think 10 minutes, more than 10 minutes are there, right? So
Yeah.
yeah, everyone, okay, so we'll continue tomorrow with this, okay? Thank you, everyone.
Yeah, thank you, ma'am. Thank you so much. We'll meet again by tomorrow. Yeah, thank you, students. Thank you for joining. Good night, everyone. We'll wind up for the day.